hidden Markov models. Here we are going to discuss what is Markov model and hidden Markov models. Okay. And we are also going to discuss what are the three central issues of hidden Markov model. That is model evaluation, most probable path decoding, model training, and application area of hidden Markov model. So these are the topics we are going to discuss in this hidden Markov models. Okay. First, we will discuss what is hidden Markov model. Hidden Markov model is a statistical model in which system being model is assumed to be Markov process. Okay, so here a system is assumed to be Markov process. Okay, so what is Markov process is nothing but it is a memoryless process. Okay, so its future and past are independent. Okay, so the future depends on means that current state depends only on the future state, that's all. Okay, sorry, current state depends upon the past state. Okay, so future and past, if you take its future and past, these are independent. And this hidden Markov model will be hidden states. Okay, so here what is that we have set of states, each of which have limited number of transitions and emissions. Okay. So we have discussed, in the temporal model, we have a transition model and observation model. Okay. So here we will be having set of states, and each of which will be having limited number of transition states and observation states. Okay. And here each transition between states has assigned probability whenever there is a transition from one state to another state. So from today's weather to tomorrow's weather, if you are finding the transition, so each transition will be assigned with some probability here. Okay. So here each model will start from start state and end in end state. Okay, because the transition, no? So one state to other state, it will be moving from one state to another state. So it starts from start state and ends in the end state. Okay. So before discussing this hidden Markov model, first we'll discuss what is hidden, and then we'll be discussing what is Markov model. Okay. So what is hidden here? Hidden is the here this hidden Markov model will be just depending on the hidden variables. Okay. So here we have discussed umbrella problem, students. In the umbrella problem, if you want to know the weather outside, okay. So how do you get the information here? So the information will be getting only through the evidence variable. What is the evidence variable? Carrying umbrella. Okay, if the director is carrying umbrella means it is raining outside. If director is not carrying umbrella means that it is not raining outside. So what is the hidden variable here is? So the hidden variable is the rain is the hidden variable. And what is the observed variable? Observed variable or evidence variable here is the umbrella. Okay, based on umbrella, we are just predicting what is the hidden state. Okay, so this is called hidden state. We don't know the information about the weather outside because so here the security guard is at the underground installation, security installation. So we don't get information about the weather outside. We will get the information about the weather only through this hidden variable, only through this observed variable. Okay. Whenever he sees the umbrella, then he assumes that he'll be getting the information about the weather outside. Okay. So here rain is the hidden variable, and what is the evidence variable is the umbrella. Okay. So that is called hidden. Then we'll discuss what is Markov model. Okay. So in the Markov model, what is Markov model? The Markov model is nothing but the current state depends upon the finite number of past state. Okay. So it is not depending upon the complete history of past state. The current state depends only on finite number of past state. Okay, that is called Markov models. Okay. So here we are taking three types of weather, students. In this example, we are taking three types of weathers. What are the weathers we have? Sunny, rainy, and foggy. These are the three weathers we have. Okay. So the weather prediction is about what would be the weather tomorrow. So what is that? Here we have to predict what is the weather tomorrow. So how do you predict the weather tomorrow? Based on the observations of past. Okay. So what is Markov model? The tomorrow's weather depends only on the the past, finite number of past. It will be taking just finite number of past states. It does not take the complete history of past state. Okay, so this is tomorrow weather. So it depends upon the yesterday's and day before yesterday weather. That's all. Okay, finite number of past states. It does not depend upon the complete history. That is called hidden Markov models. Okay. So, for example, if you want to know whether n, okay, particular day n, okay. So here every day we are measuring the weather. So what is the time slice here? The time slice is every day. We are checking the weather every day. So the time slice here is every day. Okay. So weather at some day n, how do you find out weather at some day? So the weather at some day n, we denote it as qn. What is qn? Is the weather on particular day n. Okay. So it depends upon the past weather on past days. Okay. So what is the weather on past days? It is given as qn minus 1, qn minus 2, so on. These are the weathers on the past days. So today, the particular day weather n, the day weather on particular day n depends upon the past day weathers, that is qn minus 1, qn minus 2. Okay. So this is called Markov model. Now, for example, you want to find out what is the probability of weather today based on the past probabilities. Okay, what is the weather on past days? Okay, so it means that the past weathers, what is the probability of any possible weather of today? So what is that we are finding? What is the possibility of weather today based on past days we are finding? Okay, so the probability of qn depends on what? Qn minus 1, qn minus 2, so on q1. Okay, finite number of past states. Okay, weather on today depends upon finite number of weathers on past days. Okay, so for example, we know that the weather for last 3 days. Okay, so the first day weather was sunny. The second day is also it is sunny. The third day is rainy. Okay, these are the weathers on past 3 days. Okay, sunny, sunny, rainy are the weathers on past 3 days. Okay, now the probability that tomorrow would be foggy. What is the probability that what is the weather tomorrow will be foggy is given as. So we are finding what is probability of Q4. Fourth day weather we are measuring. Q4 is equal to foggy. So it is given. It is given that the first day Q1 is sunny, Q2 is sunny, and Q3 is rainy. Based on this, we are finding what is the probability of having the weather tomorrow as foggy. Okay. So this is the formula. This is the conditional probability we have to use to find out the weather on fourth day based on the weathers on first 3 days. Okay. So like this, we have to write the equation. Now we have already discussed that there are the two types of Markov process: the first order Markov process and second order Markov process. Okay. So what is first order Markov process? In the first order Markov process, the today's weather depends only on the yesterday's weather. That is, xt minus 1 depends on xt minus 2. Xt is the today's weather, depends upon yesterday's weather, that is xt minus 1. Okay, so this is our first order Markov process. Okay, and what is second order Markov process? The second order Markov process is that today's weather depends upon past 2 days. Okay, so it depends upon xt minus 1, xt minus 2. In the case of first order, it depends only on the one yesterday, means only the one past, the immediate past condition. Okay, here it depends upon, it will consider two past conditions. Okay, that is xt minus 1, xt minus 2. Xt, weather on xt depends upon xt minus 1 and xt minus 2. So this is the figure for second order Markov process. Okay, so here we'll be taking one more example, students. So you just observe this slide, all of you. Okay. So here we have discussed. Now, what is that we have discussed here? We have discussed that in this slide. So here we have set of states of which have limited number of transitions and emissions. This set of states will have limited number of transitions and emissions. Each transition between states has assigned probability. So whenever there is a transition from one state to another state, it is having assigned probability. And what is that we have discussed? Each model starts from start states and ends in the end state. These are the three conditions we have discussed. This or no. So if you just observe this slide, all of you see this slide. So you have three states. Okay, these are the defined transition models. Okay. And what is that here? This is the evidence variable. Today's weather is the evidence variable. And these are the hidden variables. We are finding what is the weather of tomorrow. Tomorrow weather is the hidden variable. Okay. So based on like this. Okay. So if you just observe the transition, whenever it is changing from weather, if you want to find out the probability of getting foggy, if yesterday's weather is sunny, foggy, yesterday's weather is sunny. So it means that it is transiting from, there is a transition from sunny state to foggy state. Yesterday was sunny, but today is foggy. So the transition from sunny to foggy. So all this transition, this is the start state we can say, and this is the end state. Whenever we have transition from one state to other state, it is given with some probability. Here you see it is assigned with some probability. Now if you take this statement, it is sunny, tomorrow also sunny. Okay. So the start state is sunny and the end state is also sunny. Both are same. So what is its probability is given as 0.8. Okay, like that. So today's weather is sunny, tomorrow's weather is rainy. What is the probability? 0.05. Okay. So like this, whenever there is a transition from one state to other state, the transition is given with what is that here? The probability. Okay. So the probability, there is a probability assigned to each and every transition. Okay. And this is the table that gives you the transition. Okay. So if today's weather is sunny and tomorrow's weather is sunny, what is the probability? Today's weather is sunny, tomorrow is also sunny. It is given as 0.8. If today's weather is sunny, tomorrow's weather is rainy, what is the probability? It is given as 0.05. Okay. If today's weather is sunny, tomorrow's weather is 40. Okay. So what is the transition? Today's weather is sunny, tomorrow's weather is foggy. What is the transition? It is given as 0.015. So today's weather is sunny, rainy, tomorrow's weather is sunny. Today's weather is rainy, tomorrow's weather is sunny. Okay, rainy and sunny. What is the transition? It is given as 0.2. Okay. So from this table, you can draw this transition figure, or from this transition figure, we can write this table. Okay. So like this, we have to write the table that gives you the what is the probability of having the weather given what is the weather on today. Okay. So what is the weather of tomorrow based on weather today? We can find out the probability using this table. Okay. Now what is that here? We want to find out what is the weather, what is the probability of tomorrow's weather is sunny. So what is given? It is given that yesterday was rainy and today is foggy. Today's weather is foggy and yesterday was rainy. So what is the probability that tomorrow's weather is sunny? Okay. So we have given with three states. This is Q1. Q1 is rainy. Q2 is foggy. Okay. Q3 is sunny. Okay. So what is Q3 here? Q3 probability of Q3 is equal to sunny, given that Q2, that is today's weather, is foggy, and yesterday's weather Q1 is rain. Okay. So what is that here from the Markov first assumption? We know that. So tomorrow's weather depends only on today's weather. Okay, tomorrow's weather, if you are finding, it depends only on today's weather. So probability of Q3 is equal to sunny, given that Q2 is equal to foggy is given as 0.2. So what is the value here? It is given as 0.2. So using first order Markov process. So from the first order Markov process, what is that we know? We know that tomorrow's weather depends only on today's weather. Okay. So here we have discussed what is hidden Markov model, and here we are taking the example that we have already discussed, that there is a security guard at underground security installation. Okay, so he wants to predict the weather outside. How do he predict the weather outside? Based on the director carrying umbrella. Okay, so if the director is carrying umbrella, then he assumes that it is raining outside. If the director is not carrying umbrella, then he assumes that it is not raining outside. Okay, so here, uh, here we have the probability table. It gives you the probability of carrying umbrella based on weather. Okay. So if the weather is sunny, what is the probability of carrying umbrella here is 0.1. If the weather is rainy, if the weather is rainy, what is the probability of carrying umbrella is 0.8. What if the weather is foggy? What is the probability of carrying umbrella is 0.3. Okay. Now we see that what is that xi is the probability of xi given qi. Okay. So what is the probability of carrying an umbrella based on weather? So what is this based on weather? What is the probability of carrying weather? This is this conditional probability. This table gives us this conditional probability of carrying umbrella based on weather. Okay. Xi gives you the umbrella carrying, Qi is the weather. Okay. Now, what is that we have to find out? Finding the probability of certain weather is based on observation xi. Okay. So, what is that? When do you say that? Whether it is probability of getting sunny, rainy, foggy. Okay. So, this particular weather condition, how do you get the probability of this particular weather condition? Okay. So, that we'll be discussing here. So suppose the day was in the underground. Suppose the day you were in the underground, it was sunny. The next day, the director carried umbrella into the room. Okay. So first day, it was sunny. So the director did not bring umbrella. Next day, the director carried umbrella to the room. So you would like to know what weather was like on this second day. What is the weather on this second day? So this conditions gives us what is hidden Markov model. Now in the hidden Markov model will be characterized by, these are the terms students here. Capital N indicates number of hidden states. Capital M indicates distinct observation symbols per state. For each state we have different number of observations. What are the different number of observations we have for each state that we denote with M? Okay. So Aij is what? State transition probability distribution. So Aij is state transition probability distribution. BJK, what is BJK here? Observed symbol probability distribution. Okay. And what is pi I here is the initial state distribution. Pi I is given as probability of omega 1 is equal to omega I. Okay. So this gives us what is the initial state distribution. And what is theta here? Theta is given as Aij. What is Aij? The transition probability distribution. BJK is observed probability distribution. And pi I is the, what is that? Pi I is the initial state distribution. So the combination of all this will give you the complete parameter set of the model. Okay. Theta is what? The complete parameter set of the model. Okay. So in the hidden Markov model, we have discussed that we have transition table and we have observation table. So, for example, if you want to know what is the weather tomorrow, that if whether it is raining tomorrow, it depends on the weather today. Okay. So this is called transition model. Okay. So observe that umbrella carrying. So if it is raining, the director will carry umbrella. So this this part gives us the observation model, this part gives us the transition model. Okay, so the transition model will be denoted with J, and this observation symbols we have now, that we denoted with Bij, and here we have to consider what is the initial state distribution. So the initial state distribution is given as Ii. So all these three combined together will give you what the complete parameter set of the model. Okay. So like this, the hidden Markov model will be characterized. So now let's see what are the three fundamental problems with hidden Markov model. So the first problem is evolution problem, decoding problem, and learning problem. These are the three fundamental problems for hidden Markov model. Okay. So first we'll discuss what is evolution problem. So given the hidden Markov model, if the hidden Markov model is given, compute the probability that a particular output sequence was produced by that model. So we are just finding the probability of particular output sequence. That is, you want whether like the sunny, rainy, foggy. In this particular sequence, you want the output sequence. Okay, the probability of getting particular output sequence was produced by the model is given by the evaluation model. So you want what is the probability of getting particular output sequence as our output by the model. Okay. So that is called evaluation model. So this evaluation model will be solved by using forward algorithm. So here forward algorithm will be used to find out the evaluation model because these are the future state. We don't know. Okay. So that is why we are using forward algorithm to solve this evaluation model. Then what is decoding model? So here given hidden Markov model, find most likely sequence of hidden states which would have generated a given output sequence. Okay, you have particular output sequence. Okay, so what are the hidden states that will be generating that particular output sequence is called decoding model. Okay, so say for example, first day umbrella carrying, second day no umbrella, third day there is an umbrella. So these are the three output sequences we have. So we want to find out what are the sequences of hidden states, that is raining, no rain, I will raining like this. Okay, what are the hidden states that will be giving this output sequence? So this is called decoding model. So this will be solved by using vertical algorithms. Okay. So this algorithms will be discussing in the VLSI subjects. We will be usually have this vertical algorithms. Okay. Then what is the third problem here is learning problem. So here a set of output sequence. Here the set of output sequences are given. Okay. Find the most likely set of state transition and output probabilities. We have to find out what are the set of state transitions. From one state to another state it is transition. So what are the set of state transitions and its probabilities also we are finding using this learning algorithm. Okay, so this will be solved by Born-Built algorithm. Okay, this is the algorithm we are using to solve this learning algorithm. Now we'll see what are the applications areas of hidden Markov model. So hidden Markov model will be used in online handwriting recognition, speech recognition, gesture recognition, language modeling, motion video analysis and tracking, stock price prediction, okay, and many more. We have many more applications of hidden Markov model. I will see one more example, students. Here we have discussed that hidden Markov model will be having hidden state and observed state. Okay, so based on this observed state, you need to predict what are the hidden states. So we have only these are the observed state. Okay, so based on this, we have to predict what are the weathers. We don't know weather. Okay, so the particular person will be happy or unhappy based on the weather. Okay, so based on this its probabilities, we are going to find out what is the weather outside. Okay, so these are the hidden state. We don't know the weather of that particular person. We are just knowing the mood of that particular person. Based on the mood, we are just finding the probability. Okay. So this is the figure. All of you see this slide. Okay. And here we have two types of table, students. The first table will give you the transition model. Okay, what is the transition from one state to another state? It is changing. No? So that gives you the transition model. So the first matrix gives us the transition model. The second matrix will give us the emission model or observation model. So we have discussed more. So hidden Markov model will be having three terms. What are that? The first one is the initial state and transition model and emission model. These three will be having. Okay. So the first matrix gives us the transition model. Second matrix gives us the emission model. Okay. See here, how do you get this transition model? So whether it is raining today, raining tomorrow also, what is the value? 0.5. Okay. So it is raining today, tomorrow is foggy. Okay. What is the value is given as 0.3. If it is raining today, tomorrow it is sunny. What is the value? It is given as 0.2. Okay. And today's weather is foggy and tomorrow's weather is rainy. So what is its value? It's 0.4. Okay. So based on this figure, we are writing this matrix. And the particular person mood depends on the weather. Okay. So here you just see the weather conditions. It is rainy, foggy, sunny. Okay. So when it is raining, what is the probability that particular person is sad? Rainy, particular person is sad is 0.9. If it is foggy, particular person is sad is 0.6. When it is sunny, the particular person is sad is given as 0.2. Okay. Similarly, the person will be happy for this weather conditions and its probability is given as 0.1, 0.4, 0.8. 0.1, 0.4, 0.8. Okay. So this first matrix is called transition matrix. The second matrix is called emission matrix. Okay. Now we have only the observed variables. What are the observed variables? That is whether person is happy, sad, okay. So based on person's mood, you need to predict what is the weather. Okay. Now what is the person's mood? He is happy, happy, sad. So when what is the probability of the person is happy, happy, sad, given that the weather is given as sunny, foggy, sunny. Okay. So this is the probability we need to compute. To compute this probability, we are using, this is the equation we are using. It depends on initial state. And what is this called? This is called the observed model, sensor model. And this is the transition model. Okay, it depends upon the transition model and the sensor model. Okay, now we'll be substituting all these values. If you substitute all these values, we are getting the value for this probability is given as